Hey guys, welcome to Turbo Hustle, and today I will try to break down some myths on engine load. This video is all about understanding what is engine load and how it reshapes on different driving conditions. If you ask someone what is engine load, there are so many answers left out. Some would say that it is the load applied by the dyno, but it's actually vehicle load, not engine load. And some would say that it's the amount of throttle provided to your engine. But this is somewhat appropriate, but it's not exact. So coming into our topic, engine load is a direct load provided by you to your engine so that your engine will run as per your wishes. To make it more understandable, your engine load is going to be closely proportional to the manifold absolute pressure sensor's output readings. Before getting things in detail, what does a manifold absolute pressure sensor measures? As the name indicates, it measures the absolute pressure in the intake manifold. So these are some driving conditions and how engine load is going to vary on these driving conditions. Hope this will provide you a better understanding on what is engine load. Assume that you are running your engine at ambient conditions and ambient pressure at sea level is going to be 14.7 psi. So coming into our first condition, during idle, the throttle opening is going to be almost 0%, which means your throttle is going to be remain almost closed. So due to the intake stroke, a suction pressure is induced and will produce a vacuum in the intake manifold, which will reduce the absolute pressure to 9.8 psi, which makes the engine load to be minimized. So to the second condition, at cruising conditions, assume that your throttle opening is around 50%. Since in higher RPMs the suction pressure is going to be more, and due to 50% throttle opening, your outside ambient air pressure is going to influence your intake manifold pressure. So there is a rise in the pressure to 12.2 psi, which means the load is higher than this. And coming into a third condition, assume that you are in idle position and you are suddenly stepping on the gas pedal. Your throttle position is going to be fully open, which means 100% opening. So when your throttle is going to be 100% open, your ambient air pressure and the absolute manifold pressure is going to be somewhat equal, but due to some restrictions in the intake side of your engine, it's going to be lesser than that of the ambient air pressure. So here its engine load is going to be very high compared to both these above conditions. So now coming to the next condition, sudden deceleration. Assume that you are running your engine at very high RPM and you are letting off the gas pedal all of a sudden. Then your throttle position is going to be closed, which since higher RPM produces higher suction pressure and you left your throttle fully closed, your pressure is going to drop beyond this 9.8 psi mark, and this is going to be the very low engine load which is possible in an engine. Now coming into the next part, sudden deceleration and braking. The same thing happens during sudden deceleration. It's going to go beyond this 9.8 psi. As the engine pressure, as the engine RPM decreases, the suction pressure also decreases. So which means after as the engine RPM decreases, your pressure is going to increase and get into that 9.8 psi mark. Here also the engine load is very low. And coming to the final part, hard acceleration at higher RPM. At hard acceleration, your throttle opening is going to be 100%, and this is where your engine is going to have the highest load possible. Hope this will provide you a better understanding on what is engine load and how it varies on different conditions. These numbers are just for understanding purpose and it's not accurate. For any queries or suggestions, put your comments on the comment section, and for more videos subscribe to Turbo Hustle.